Today we are focusing on one of the most critical aspects of aviation safety, the pre-flight checklist. We chose this topic because a systematic approach to aircraft inspection is the primary method to prevent human error before the takeoff. While there are many types of aircraft, we decided to demonstrate this process using the Cessna 172 Skyhawk. The choice is practical as, well, the Vilnius Tech uses these specific aircraft for flight training, making it a relevant model for our university's aviation community. And our main goal is to justify why following a checklist is a mandatory safety requirement, not just a recommendation. Using the X-Plane 11 flight simulator, we will show the essential cockpit procedures, focusing on before starting engine and engine start sequences. We want to highlight how professional vocabulary and discipline routines ensure that the aircraft is airworthy and ready for flight. By analyzing safety procedures, we will provide a clear view of how the pilot's focus during these first few minutes on the ground determines the safety of the entire mission. So, let's begin our demonstration. Here, we can see that the aircraft is in a cold and dark state. For the purpose of demonstration, we are going to hide the yoke, turn on all the batteries. We can see that the aircraft has come alive. Maybe you can even hear it. So, first thing first, turn on all the main lights, outside lights specifically. We want to ensure that all of them are working and all of them are in proper order. Second, we must lower the flaps to their fully open position, fully extended out, so that we see that if there's anything blocking the movement or hydraulic lines or anything similar to that. So, as we just did that, we go outside. Here we can see that our, well, at least beacon, navigation, strobe, landing and taxi lights are intact and working in order. As we are outside, we can see that there's no wheel chokes, nothing is blocked. If this would be real life, we would move all of the flight surfaces or control surfaces with our hands to see if they move freely, if everything's alright, looking proper and intact and clean and nice. And we can see, well, lucky for us, everything is nice and cool. So we may continue our pre-flight checklist. So, turn off all the exterior lights except for beacon, as we're going to be turning on the engine, if you remember the beacon lights purposes. So, turn on the fuel pump, make sure that the mixed lean is fully engaged, center tank is selected, give it a bit of a throttle, like about 1/4, magnetos, left, right, both, and turn on. And we are good. We now can turn on the rest of the essential lights. We're going to turn on the taxi lights, well, as we're going to taxi all of our avionics systems. And we're ready. The pre-flight checklist is done. Now we are just taxiing to the runway.
Now, we have explained what a pre-flight checklist is and how it works. It's important to talk about something equally critical, the problems and limitations of checklists, and how we can improve them. Even though checklists are designed to increase safety, they are still used by humans, and humans are not perfect. One of the biggest problems is getting too used to something. When pilots do the same checklist hundreds or even thousands of times, it becomes a habit. Instead of carefully checking each item, they may start saying and answering it from memory. This is sometimes called checklist fatigue. The danger is that when something is slightly different, maybe a switch is in the wrong position, the brain may overlook it because it expects everything to be normal. Another major issue is time pressure. In busy airports, especially under commercial operations, crews may feel pressure to avoid delays. This can lead to rushing through the checklist. Even a small distraction like radio communication from ATC can interrupt the flow, increasing the chance that an item is skipped. There is also a problem of distractions and interruptions. Modern cockpits are highly dynamic environments. Phone calls from ground crew, passenger questions, maintenance discussions, weather updates, all of these can break concentration. Research in aviation human factors shows that interruptions significantly increase the likelihood of errors. A further challenge is poor checklist design. If a checklist is too long, poorly organized, or not logically structured according to cockpit flow, it becomes harder to use effectively. Some older checklists were written more like technical manuals rather than practical operational tools.
So, how can we improve it? First, better checklist design. Modern aviation increasingly uses the challenge response format, where one pilot reads the item and the other confirms it physically. This creates active verification instead of just passive reading. Well designed checklists follow cockpit flow patterns and group related systems together, making them more intuitive. Second, electronic checklists are becoming more common. Many modern aircraft, such as the Airbus A320 and Boeing 787 Dreamliner, they use integrated digital systems that can automatically sense certain aircraft configurations. These systems can highlight incomplete items or warn the crew if something critical is not set correctly. This reduces reliance purely on pilot's memory. Finally, fostering a safety first mindset is essential. Airlines and flight schools must reinforce the idea that no delay is more important than safety. Taking an extra minute to carefully complete a checklist is always better than skipping a critical step. In conclusion, pre flight checklists are one of aviation's strongest safety tools, but they're not perfect. Human factors, distractions, poor design can reduce their effectiveness. By improving checklist structure, using technology, strengthening communication, and prioritizing safety, we can make this already powerful system even safer.